Hello everyone. In the previous lecture, we had discussed about some applications of the direct sequence spread spectrum. Uh, and before going into frequency hopped spread spectrum, let us first understand what are the advantages and disadvantages of direct sequence spread spectrum. Here, the advantages are very straightforward as the applications. The direct sequence spread spectrum has best discrimination against multipath signals. It avoids intentional interference such as jamming effectively. Performance of direct sequence spread spectrum in presence of noise is better than frequency hopping spread spectrum systems, which we are going to study in the next uh, few slides. And the disadvantages of direct sequence spread spectrum. Now, uh, because there are some drawbacks in the direct sequence spread spectrum, we are going for frequency hopping spread spectrum. What are the drawbacks? First one is this system becomes slow due to a large acquisition time. This acquisition time is nothing but, in a way you can say, it is chip rate. The PN sequence to be generated should have very high uh, sequence or chip rate, and because it is generated through some hardware shift registers, there is a physical limit on the sequence generation. Thereby, our uh, direct sequence spread spectrum has a limitation in generating high rate pseudo random codes. Okay, this is the basic disadvantage of direct sequence spread spectrum. So to overcome this, we go for frequency hopping spread spectrum. The other two disadvantages are also in line with the first one only. You can see it requires wideband channel with small phase distortion. Phase distortion required is very small, but since uh, the as the rate chip rate goes on increasing, phase distortion also will not remain small. It will become large and reliability will be lost. Similarly, the pseudo noise generator should generate sequence at high rates. There is a physical limitation on the hardware which we use. Okay, because of this we go for frequency hopped spread spectrum. Let us see what is frequency hopped spread spectrum. Here in FHSS, the spectrum of data modulated carrier is widened by changing the carrier frequency in a pseudo random manner. So, what is the difference between direct sequence spread spectrum and frequency hopped spread spectrum? That is, here we are changing the modulated signals frequency in a pseudo random manner. That is, now modulated using M-array FSK, we can change this signal's frequency, translate this signal frequency in a pseudo random manner. Instead, in direct sequence spread spectrum, what we used to do, we used to take a input bit stream and we used to multiply with a pseudo random sequence, and thereby we used to convert it into a wideband channel, and then we used to modulate using BPSK. Correct? That was the process in direct sequence spread spectrum. But here we are not first multiplying the pseudo random sequence or PN sequence into the message signal itself. We are first modulating the message with M-array FSK. Consider BFSK, where one bit is represented by one frequency, another bit is represented by another frequency. What happens? There are two frequencies now. The signal is modulated, but it is a narrowband modulated signal. Okay, this narrowband modulated signal consisting of say frequencies f0 and f1, they are frequency translated using different carrier frequencies. And how these different carrier frequencies can be generated? They can be generated by uh, the circuitry involving pseudo-random number, the sequence generator along with frequency synthesizer. Okay, and thereby we are going to add this carrier frequency generated pseudo-randomly with the signal, modulated signal involving one frequency for one bit, another frequency for another bit. Okay, and since this pseudo random code is generated and the frequency changeover is also random, we can have different frequencies for the same bits in different time instants, and thereby it will be a kind of robust or secured way of communication. Okay, the next point is, in this method the available channel bandwidth is subdivided into a large number of non-overlapping frequency slots. That is, if you are given with 1 megahertz bandwidth, you may divide it into 10 equal slots, like first 10 kilohertz is fc naught, that is from sorry, 1 megahertz bandwidth means 100 kilohertz slots you can do. First 100 kilohertz is fc naught, 100 to 200 will be the fc1, likewise fc2, fc3, fc4, fc5 up to fc9. You can have 10 different slots, and they can be, these frequencies can be randomly accessed by different bits using the particular circuitry designed for frequency hopping. And this selection of the frequency slot is made pseudo randomly according to the output from a PN generator, as already explained. This particular explanation will understand better if we go through the block diagram of FHSS, which is this one. Let us first see the modulator or the transmitter end. Incoming information sequence is applied to an encoder. Okay, here the encoded signal is frequency modulated. I have considered an example of BFSK. We can use 4 array FSK, 8 array FSK, but for simplicity I have considered one bit is represented by a higher frequency, bit 0 is represented by a lower frequency. And this signal is given to the mixer. What mixer does? It mixes two incoming frequencies. It generates some frequency and difference frequency. And what is the another input for this mixer? It is the output of frequency synthesizer. This frequency synthesizer generates different carrier frequencies like fc0, fc1, fc2, fc3, fc4 based on the random sequence generated by PN sequence generator. It randomly generates 0, 0, 0, 1, 0, 1, 0, 0, 1. This is not in the order, okay? You can see. Randomly it goes on generating. Based on particular sequence, it generates a particular carrier frequency. And this carrier frequency is added with either this high frequency or with this low frequency. And also we need to understand fc fc0 to fc4, which I have indicated here, they are much larger than these frequencies. Okay, so frequency translation takes place at the mixer, and this signal is applied to a band pass filter. Here it is not shown, but in practically we apply it for a band pass filter. It passes only the sum frequency. This frequency summed with fc0 will be passed. Fc0 minus this frequency will be removed. Okay, because only one frequency we want per sequence, and the same fc naught can be used for this also. So as the sequence changes, the frequency which is to be added or translated with this frequency will go on changing, and thereby we are going to get a randomness in the frequency, or this change in frequency is called as hopping. Hopping means jumping from one frequency to the another frequency randomly. Okay, and the signal is finally transmitted through a channel. Now at the receiver end, what happens is the incoming signal is directly applied to the mixer. Why? Because we want to remove this high frequency carrier first, then we demodulate. This is modulator, right? This is frequency translation. Now the received signal, let us consider fc naught plus this frequency, say this has f naught. Fc naught plus f naught is there. At the mixer we will have the same PN sequence generated, and the similar kind of FC naught will be generated, but the difference is now it is having a band pass filter which will allow only the frequencies of the difference. The incoming frequency is now FC naught plus F naught. This mixer will generate FC naught plus F naught plus FC naught, FC naught plus F naught minus FC naught. It will allow only fc naught plus f naught minus fc naught. That means fc naught and fc naught will cancel out. Only f naught will be there, and that f naught is this one, right? Again, when we apply this signal to FSK demodulator with timing synchronization given, which is used at the transmitter, we can easily demodulate the signal as bit 1, and this bit is not directly transmitted, right? It is encoded, correct? So it is given here to decoder, which will decode the signal, and output can be used by any intended user. I hope you have understood the FHSS block diagram, that is transmitter and reception. The same has been explained over here. You can just go through it. This is about the receiver, and this is our example of FHSS, our frequency hopping spread spectrum, which we will discuss in the next session.